Okay, so I applied the aluminum sheet, 2 aluminum sheets, and I bend it and deformate it. This is a foil type aluminum, very thin, very thin. And I applied coils on the top, which is connected to the magnetic suspension coil at the bottom of it. I have to add the other one that's localized here, the propeller for the armature of this small motor right here. I have to add the propeller, which is a permanent magnet, and it rotates the permanent magnet synchronized induction into the coil. Another one goes alongside here in the frontal, for the frontal coil, and another permanent magnet propeller rotates and causes the coil to induce currents into the coil. I've added a magnetic suspension coil right here along the side for the blade to switch pitch. I turn here and here. So these are on 2 opposite sides to repulse this way and to repulse this way. The coils that I have underneath are over 200 turns. It's magnetic suspension coil, magnetic suspension coil, magnetic suspension coil, magnetic suspension coils right here and here and here. Here, 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 and here, 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 and here. So this is for the lower part. Then I have a pancake magnetic suspension coil with permanent magnet central. And I have a winding coil that goes around here, around the base of the cockpit, just the bottom of the cockpit for the suspend. This is pull, this is push. I have a linear motion going here, and I have a push motion going up. So one push motion going up, while another is a linear motion forward. Now, here, lying here, I have magnetic suspension coils right here, so it may move the aluminum away from itself and force itself forward by the repulsive force against the aluminum. It will shift it forward because the flap is down that way, facing vertical. However, the levitation moves to, this is about more than 200 turns, so it's over 200 turns twice. So it's about 400 over 400 turns, so 2, 4, 6, about 682 turns. About 682 turns, where I can achieve about 10 pounds every 200 turns, so that's about 20 pounds. 5 pounds, so that's 10 pounds. That's actually 10 pounds every 200 turns, so that's 10, 20, that's 20 pounds in addition to, that would make 400 turns for 20 pounds. And it's mounted on paper. This is a film like plastic, and I designed it out of film plastic, and the coils and bearings are on it. The only misfortunate thing that I did not do was add the plaster with the silicon. I did not add the plastic with the silicon underneath the aluminum. The aluminum is on top, and it suspends the aluminum into the air and causes it to escape. So the inertial mass of the aluminum is not greater than the emission, the transmission of ions against it, and the repulsive ions against it. So because the transmission is actually forces away the aluminum, it also yanks the coil into the air along with it. So at the same time, to suspend them both, however, not moving in the opposite direction, but against, which is being forced away, which is the aluminum being forced into the air. And being that the aluminum is a low gauge and the winding coil is very thick, it's a lot. And it should have enough energy to lift them both into the air and move forward. So this is a design of Star Wars, one of the Star Wars vehicles that I was designing, and I had to finish it off and put also the permanent magnet propeller here, and that would induce currents to the side coils that are along the side right here. I put my finger right to it. And my name is Jermaine Morton, and have a good day. This is self-repulsive Star Wars RC vehicle, synchronous electromagnetic pulse phase 1. My name is Jermaine Morton. Have a good day.